19. Which object will have the greatest change in electrical energy? Okay, so it's not so much a math problem, but more of a conceptual. We want to know about the change in electrical energy. Well, what is electrical energy? If you look on your formula sheet, you'll find the descriptions of each of the different parameters and what they are in words. And for work, on the sheet with the electrical formulas, there it says work, and then in parentheses it says electrical energy. So even if you didn't know before the Regents, they've given you the key words. So basically they're saying, for which of these scenarios will the most work be done? And let's look at the different scenarios. An electron moved through a potential difference of 2 volts. So potential difference is the same way of saying voltage, but sometimes it's helpful to think of it as potential. It's like if there's a voltage, there's a potential for electric charge to travel, which is to say it'll do work. A metal sphere with a charge of 1 times 10 to the negative ninth coulombs. So what's the charge of an electron, by the way, from the first one? We said in the last problem that it's 1.6 times 10 to the negative 19. So the charge of an electron is only 1.6 times 10 to the negative 19. This metal sphere has a much bigger charge. It's 1 times 10 to the negative ninth. So it's many, many times larger than the charge of an electron. Let's just keep that in mind. And 3, an electron moved through a potential difference of 4 volts, so higher voltage than in 1. And a metal sphere with a charge of 1 times 10 to the negative ninth coulombs, so same charge as in 2, moved through a potential difference of 4 volts, so higher voltage. So we got these situations where we have lower charges in 3 and 1, because they're electrons, but different voltages. And in 2 and 4, we have the same charge, but different voltages. So do we want a high voltage or a low voltage? And do we want a big charge or a small charge? Well, to figure that out, there's a formula that says V, that's the voltage or potential difference, equals work, which is the electrical energy, over Q, which is charge. And we can rearrange that by multiplying by Q on both sides so that we get work equals voltage times charge. And then what this tells us is that if the voltage is larger and the charge is larger, then that is what's going to give us our largest work. If either of those gets smaller, that's going to make the work smaller. So if we want the maximum electrical energy, the greatest change in electrical energy, we want to pick the one that has the biggest voltage and the biggest charge. And that is 4. Because 1 times 10 to the negative ninth is much bigger than the charge of an electron, and 4 volts is more than 2 volts. So 4 is the best choice.